Welcome back to part 4 of probability, and this happens to be our final part on probability. We are looking at the 6th and the 7th rule of probability in that case. So if you are new, kindly consider to subscribe, like and share, and kindly check the description section of this section. I've given the link of the previous video I've done so far, so you can watch and build understanding from there up to this point. So let's continue straight away with part 4 of probability. So we are continuing with rule number 6, which is an independent event. An independent event. We are saying that two events are independent if the occurrence or non-occurrence of either the two events does not have an influence on the occurrence or non-occurrence of the other. So taking, let's say I have an event A and what event B. If A occur or it doesn't occur, the independent rule is saying that whether A occur or does not occur does not have any influence on B occurring or it does not occur. That is what the independent event is actually telling us, that the occurrence of A or non-occurrence have no influence on what the other event, which is what the B. Likewise, the opposite is true. Likewise, the occurrence or non-occurrence of B also have no influence on the event what A. And in that sense, both occurrence or non-occurrence has no influence on the other, then we can say that we can have the two events. We can have the event A and B to occur at the same time and becomes what? Independent what? Event. So the two events can occur at the same time, so it becomes what? An independent event. Since the occurrence or non-occurrence of A or B does not have any influence on B, then we can say that A and B are independent events, and then they can happen at the same time. So if they can happen at the same time, then we are saying that A and B both can happen at the same time. So we can denote by saying that if A and B can happen at the same time, then we can say that therefore the probability of A and B can be written as the probability of what? A intersection what? Because we said intersection is the same as what? And B. And once you heard of what? And is what? Multiplication. So the breakdown will be probability of what? A multiplied by the probability of what? B. Since the occurrence or non-occurrence of A has no influence on B, and likewise the occurrence of A or non-occurrence of A has no influence of A, it is certain that both events can happen at the same time. And when they are happening at the same time, that's where you have an intersection of A intersection B, or you have probability of A and what? B, and that will result in probability of A multiplied by probability of what? B. So this is what we call the multiplication what? Law of independent what? Events. So this is what we call the multiplication law. The multiplication law of independent event. Multiplication of independent what? Event. So these are the multiplication law, this law. So where two events are suddenly to happen at the same time, then we say that such events are what? Independent. They don't depend on one another. Such as occurrence or non-occurrence does not affect the other. So they can happen at the same time. So let's take an illustrative question to illustrate what we are saying so that you appreciate it more better. Alright? So let's see. So this is an illustrative question to actually explain the principle of independent event. So let's take it real quick. A bag contains 4 white and 3 black balls. Another bag also contains 3 white and 5 black balls. One ball is chosen from each bag. Find the probability that A, both balls are black, B, the two balls are for the same color, and C, the two balls are of different what color. So this is what we're going to do in this case. So first, have my solution down. Let's see. The first thing that you need to do is to have a representations of each bag in terms of the balls that it contains. Okay, so I can say that let the first bag, let's say bag X, have it as bag X, and within bag X we have 4, let's say number of white balls to be what, 4. Okay, and then number of what, black balls to be what, 3. Then we come for, let's say bag Y, number of white balls is what, 3, and number of what, black balls in bag Y is what, 5. All right, so if you want to talk about the total balls in X, we can say that is what, 4 plus what, 3, and that will give me what, 7. Okay, then if you want to know the total number of what bag Y, it's also the same, 3 plus 5, and that will give me what, 8. I hope that is clear. Good. So once we're able to establish or give identification of these bags that we have, the next thing you go on to is to answer the question. A. The question is saying that what is the probability, or find the probability that both balls are black. So meaning that both bags are of the same what color, that's black. Is that okay? They are black. So meaning I'm going to pick what, the black ball from bag X and a black ball from what, bag what, Y. And since, because these, we have 2 bags and these balls are coming from 2 bags, when a black ball in bag X occur, it has no effect on what happened in bag what, Y, because they are all for different what event. And I mean, X is a different bag altogether, Y is also a different bag. So when I draw a ball from bag X, it doesn't have any relation or don't have any influence on bag Y. So that's why we call it an independent what event. Okay, so the occurrence of what is happening in the X has no influence on what happened what in the Y. So that's why it makes it what, an independent event. So here I'll say the probability of having both blacks to be what, so I'll say B of X intersection, and you are saying that once they can occur at the same time, we use intersection to denote B of what, Y, and that can be P of what, Bx multiplied by P of what, By. Okay, so at the end of the day, it becomes, what is my P, probability of what, black ball, which is what, 3. So it's 3, number of black ball is what, 3, and the total sample space was 7. So it becomes what, 3 out of 7 multiplied by, then Y, black is what, 5, divided by what, the total sample is what, 8. So at the end of the day, my result is going to be, my result is going to be 15 out of what, 56. And this is the approach for what, an independent event, because what is occurring in X has no effect on what is occurring in Y, and likewise what is occurring in Y has no effect on what is occurring in what, X, because you have different bags altogether. So whatever happens in each bag has no effect on the other. So each events can happen at the same time. That's why we call what? An independent event. And once they happen at the same time, we use what we call what? End. And end means what? Intersection. And that will lead us to what we call multiplication law. We're going to multiply. All right. B. Let's look out for the B part of this. So B, they are saying that the two balls are of the same color. So if they are of the same color, then I can first of all take the option 1 here, which is the black one, then deal with it. So it can be that it is probability of what? B of X intersection B of Y, or it can be probability of what? W of X intersection W of what? Y, because it says they are of the same, two balls are of the same color. We don't know whether it's two blacks or two whites, so we don't know. So either we go for two blacks or two whites. So once you heard of or, it means what? An addition. All right, good. And you know that probability of B of X intersection B of Y is this. All right, so I can show that with my substitution. So I can say that here it is equal to my 15 out of what? 56, okay? Plus, then here, my probability of what? Y in probability of white ball in the Y bag will be what? 3 out of what? 8, okay? Multiply by, X, rather. White, X. Here is X, so here should be 4. I was dealing with. So let's follow in that chronological. So 4 out of 7 multiplied by here, which is what? 3 out of what? 8. And when you compute the total, the effect is true. So we are adding 15 over 56 plus 4 over 7 multiplied by 3 over what? 8. And the result will be that. So I'll be having here 15 over 56 plus 12 over what? 56. So when I compute for this, I had 12 over 56. So when I add to this, I'll be getting 27 out of what? 56 in that case. So let's take note of that. So that is the B part of the question. So let's move on to the C part of the question. And in the C part, they told us that we should find what? The probability that two balls are of different what? Color. Two balls are of different color. So if two balls are of different color, that's the probability you are finding. Then we can say that for us to find two balls that are of different color, we are going to take into account balls that are of the same color and subtract from 1. So we are going to apply the complement rule so that we get balls that are for two balls that are for different in colors. Besides, get what I'm saying? So that's what we're going to actually do. So here we are going to use balls of the same what? Color. So we realize that balls of the same color were giving us what? 27 over what? 56. So for me to find what? The probability that there will be different two balls of different colors, then so I can say that probability of what? Balls are of different what? Colors. Of different what? Color, sorry. Balls of different color or colors would be, so here it's going to be this is what it's going to be. Going to be 1 minus the probability of balls of the same color. This is what it's going to be. Balls of the same color, right? Sure. So once you're able to establish that, then we can say that it is 1 minus 1 minus what is the probability of the same color, which was what? 27 out of what? 56. So the result then going to be 29 out of what? 56. So let's use a calculator and let's see whether I get the same thing or not. So that's actually how it is actually undertaken. Okay. So anytime you want to find the complement form of what, the probability, that is how it should be. So here, because the requirement of the question is that we have to find balls of different color. That's why we subtracted balls of the same color from 1, and that will give us the balls of what, different color. Somebody might also go by a different approach. You might still get the same what result, irrespective of the approach that you actually take. You can go for, you have a long way of going to. You can use that approach and still come to this, arrive at this what answer. There's no problem with that. So you can also do that. So that is independent what event. So let's move on straight away to the last part of rules and probability. That is the conditional what probability. So let's look at that one too in that case. So if you have any question, please kindly put below in the comment section, and I'll give you responses to that. All right. So this is our last rule under probability, though you have much, but for the purpose of this video, this is the last rule that we discussed under probability, conditional what probability. We are saying that if I have two events, let's say event X and event what? Y. We are saying that under conditional probability, the probability or the chance of an event Y occurring would depends on whether Y has occurred or not. All right, S occurring rather would depends on whether Y has occurred or not. Or it can be that the chance of Y occurring would depends on whether S has occurred or not. So under conditional probability, we are saying that the probability of an event is certainly to happen where another event has what occurred. So if X is certainly to happen, then it should be true that Y has already what happened, or Y has already what occurred. That's what we call a conditional probability. So if that is so, for me to find what the probability of X, it will depend on whether the Y has occurred or not. Then also for me to find the probability of Y occurring also depends on whether S has occurred or not. That's what we call a conditional probability. For an event to occur would depends on whether other event has occurred or not. And if it has occurred, then we can say that the probability that S will occur given Y, or stating that Y has occurred, would be X slash Y. This is how it's going to be X slash Y, and it's equal to. So here it means that is the probability that X is yet to occur given Y. All right, so here it becomes what? This is a breakdown. This is how we actually represent the breakdown of what this. So it becomes the probability of X intersection what? Y all over the probability of what? Y. So meaning that for X to occur would depends on Y occurrence that has already occurred. That's what we mean by what? A conditional what? Probability. So conditional probability will always occur where an other event has what? Already occurred. That's what I mean by a conditional probability. So if I also have, let's say, a probability of what? Y slash X, will mean that S has already occurred, but we want to find a probability that Y also occurs. So in that also be what? Help me to write P probability as P. Let's go. So it becomes what? Y intersection what? X all over probability of what? X. So this is what we mean by what? Conditional what? Probability. Conditional what? Probability. So let's take note of that. Remember, probability y intersection x or x intersection y, they are the same. So therefore, I can conclude that when it comes to conditional probability, I can say that if I want to make probability of x intersection y the subject, I can say that here it becomes probability of x intersection y can be this one multiplied, so it becomes what? Probability of y multiplying probability of x slash what? Y. This is how it's gonna be. Likewise to here too, if I want to find the probability of this intersection, it becomes y intersection x. Also going to be the same thing, probability of x multiplying probability of y slash what? X. This is what we call what? A conditional probability. Conditional probability. So you can clearly see that here and here are equal. Alright? And if I want to strike, I can do so and I can equate. So in that, we can have certain relation that will exist between when these two events interchange based on the one which has already occurred. So that is a tidbit of what a conditional probability. So let's take a question to clarify this rule under probability. So this is an illustrative question to explain conditional probability. In a group of 100 sport car buyers, 40 bought alarm systems, 30 purchased basket seats, and 20 purchased an alarm system and bucket or seat. In a group of 100 sport car buyers, 40 bought what? Alarm systems, 30 purchased bucket seats, and 20 purchased an alarm systems and bucket seat. If a car chosen at random bought an alarm system, what is the probability that they also bought bucket seats? So when you're answering a question under conditional probability, the things that you need to look out for, or the first thing you need to look out for, is look out for which event has occurred. That based on that, we can also make estimation of the other event that will occur. So you must always look out for the event that has occurred in the circumstance or in the situation, so that you use that as a base for us also to find the probability of the other event that will be occurring. So in a question, you can clearly see that one event has occurred. And what is it? If a car chosen at random bought an alarm system, so the alarm system here becomes what? A event that has already occurred. What is the probability that they also bought what? A bag. So first thing that you need to identify is here, you must identify your, so let's say, let the alarm system, because we have 40 alarms, so let the alarm system be probability of what? X. All right, and that represents as what? 40. And then let the probability of Y also represent the basket, which is what? 30. But then in a question here, we are given that 20 purchase an alarm system and what? Basket. So what would you think going to be? It's going to be with an intersection, which is probability of what? X intersection Y, which is what? 20. So now, which probability are we finding? We are finding the probability that they also what? Bought what? A basket seat. And the basket we have represented as what? Y. So this is how I'm going to have my expression. I'm going to write the probability that a basket will occur will be what? Y slash my X, which has occurred, and will be equal to the probability of what? Y intersection what? X. Okay, all divided by the probability of X, which has already what? Occurred. I hope that is clear. So here, straight away, it becomes, sorry, is what I'm saying. Once X has already occurred, that the but, and we are asked to find probability of bucket 2 that they also bought. This is the approach of the conditional probability. All right, so here it becomes, what is my Y intersection X or X intersection Y? Okay, for the purpose of understanding, let me use here as Y so that everything is clear. Then here is what? X, based on the arrangement. So I can say that my probability of Y intersection X is what? 20. Okay, and then my probability of X that has already occurred is what? 40. So in other words, it's going to be 1/2, which I can say that the probability of they also buying the bucket is also what? 50%. I think you can convert to percentage, nobody will harm you. But then if think you convert to percentage, you get a mistake, just leave in a fraction form. So this is actually how we go by conditional. So first thing you must identify in the question is to identify which event that has already occurred, so that we use that event that has already occurred as a base for us to find the probability of the event that is yet to what? Occurring. And that's what we mean by what? A conditional probability. We find a probability based on an event that has already what? Occurred. Okay, so that is what we mean by what? A conditional probability. So there are more questions out there that you can go through and solve a lot. Based on knowledge I derive here, you can use the same approach and tackle those questions in there. So I'll urge you that you go online, search for more questions, and then solve, so that you abreast yourself with how these kind of questions are solved. So this is where we bring an end to the part 4 under probabilities. So thank you once again for watching this video. I'm very grateful to have you here. If you are new, and don't forget to subscribe, like, and share. So I'll see you where I come away with other videos to help you. Make sure to like this video so that you can get to as many students as possible, so that your YouTube algorithm also will push this video to people to also watch and then have a benefit of this channel. Thank you once again. I'll see you. Bye bye.